January 1945, Western Europe. A frozen field bordered by shattered trees and blackened farmhouses. Inside a German Panzer IV, 5 men sit shoulder to shoulder, wrapped in wool and steel. The engine vibrates beneath their boots. Condensation clings to the inside of the armor plates. They have fought before. They trust this machine. Its armor has deflected shells. Its silhouette has survived artillery and air attack. Across the field, an American Sherman idles, smaller, louder, thinner-skinned by reputation alone. The German gunner tracks it calmly. There is no urgency yet. The Sherman is known for burning when hit, not for killing first. Then the American gun fires. The shell does not punch through the armor. It does not arrive with the clean violence of penetration. Instead, it bursts against the metal, releasing a white cloud that seeps through vision slits, seams, and vents. In seconds, the interior temperature rises. Smoke thickens. Oxygen vanishes. Paint blisters. Ammunition begins to cook. What happens next will force German tank crews across Europe to reconsider what armor truly protects against, and it will mark a turning point in how battlefield survival is understood inside steel. By the time the Second World War began, Germany had already redefined what armored warfare meant. In the 1930s, German military planners rejected the slow, infantry support tanks of the First World War, and instead built a doctrine around speed, coordination, and shock. Panzer divisions were not meant to operate alone. They moved with infantry, artillery, engineers, and aircraft, all linked by radio. This system, later labeled Blitzkrieg, was designed to collapse enemy defenses before they could react. In Poland in 1939, and again in France in 1940, it worked with devastating effect. German Panzer IIs and early Panzer IVs were not always superior in armor or firepower, but they were used with precision. French and British tanks were often stronger individually, yet they fought dispersed, without communication, and without air support. German crews learned early that confidence inside a tank came not only from steel thickness, but from doctrine and momentum. As the war expanded eastward in 1941, German armored forces encountered a new challenge. The Soviet T-34 shocked Panzer crews with its sloped armor, wide tracks, and diesel engine. It was not invulnerable, but it forced German designers to rethink protection and firepower. The response would eventually produce the Panther and the Tiger, tanks built around the idea that superior armor and heavier guns could restore battlefield dominance. Across the Atlantic, the United States was watching closely. When America entered the war in December 1941, it did so without a modern combat-proven tank force. U.S. armored doctrine had developed differently. American planners emphasized mobility, mechanical reliability, and mass production. Tanks were expected to support infantry, exploit breakthroughs, and be easy to manufacture and repair across continents. The result was the M4 Sherman. Introduced in 1942, the Sherman was not designed to duel the heaviest enemy tanks head-on. Its armor was thinner than later German designs, and its main gun, initially a 75 mm, was optimized for high explosive fire rather than armor penetration. German crews encountering the Sherman for the first time often noticed its height and angular shape. They noticed how many of them there were, and they noticed how quickly they burned when penetrated. These observations hardened into belief. German after-action reports from North Africa and Italy repeatedly described the Sherman as inferior in protection. Crews referred to it dismissively, sometimes calling it a Ronson, a nickname later popularized but rooted in real battlefield perception. The assumption was simple: hit a Sherman first, and the fight would end quickly. Yet this assessment missed something critical. American armored doctrine did not rely on single tank superiority. It relied on coordination, artillery, air power, and logistical depth. Shermans were rarely meant to fight alone. They advanced with infantry, engineers clearing obstacles, forward observers calling in fire, and fighter bombers circling overhead. If a tank was lost, another often took its place within hours or days. Equally important was ammunition. By 1943, American tank crews carried a variety of shells for different battlefield problems. Armor-piercing rounds were used against tanks. High-explosive shells suppressed infantry and destroyed field positions. Smoke rounds screened advances and blinded enemy gunners. Among these was a type of round that German crews often misunderstood until it was used against them: white phosphorus. White phosphorus was not new. It had been used since the First World War for smoke generation and signaling. When employed by U.S. armored units, WP shells served multiple purposes. On impact, they produced dense smoke that clung to surfaces and burned at extremely high temperatures. They could blind optics, ignite external equipment, and, under certain conditions, infiltrate enclosed spaces through vents and openings. Against a tank, WP did not need to penetrate armor to be dangerous. This reality would collide violently with German assumptions as the war moved into Western Europe, where terrain, visibility, and pressure transformed how armored battles were fought, and where the interior of a tank became just as vulnerable as its steel shell. By 1944, the armored war in Europe had changed fundamentally. The open deserts of North Africa and the wide plains of Eastern Europe gave way to the hedgerows of Normandy, the mountains of Italy, and the dense villages of France and Belgium. Visibility was limited. Engagement distances shrank. Tanks no longer saw each other across kilometers of open ground. Instead, they appeared suddenly at road junctions, field edges, or behind stone walls. For German armored units, this environment eroded many of their advantages. Heavy tanks like the Panther and Tiger were formidable at range, but they were also large, mechanically complex, and difficult to maneuver in tight terrain. Their thick frontal armor offered confidence, sometimes too much. Crews trusted that American shells would bounce. Often they did. The Sherman, by contrast, thrived in constrained conditions. Its reliability allowed it to operate continuously. Its turret traverse was fast. Its optics were clear. And most importantly, it worked as part of a system. Infantry advanced alongside it, pointing out threats. Engineers cleared paths. Artillery softened positions ahead. When a Sherman fired, it was rarely the only weapon engaged. American armored units also adapted quickly. Combat reports from Italy and Normandy reveal a constant exchange of lessons between crews and commanders. When direct armor-piercing fire failed, crews used smoke to blind enemy gunners. When smoke failed, they closed distance. When distance closed, they aimed for tracks, vision ports, and crew morale rather than armor thickness alone. White phosphorus ammunition fit into this adaptive approach. Officially, WP rounds were classified as smoke. They were intended to obscure enemy observation and mark targets. But in practice, their effects were more severe. On impact, white phosphorus ignited instantly, producing thick white smoke and intense heat. It adhered to surfaces and continued burning until deprived of oxygen. Against open targets, it caused fires. Against fortified positions, it forced defenders out. Against tanks, its danger lay in confinement. German tanks, like all armored vehicles of the period, were not airtight. They required ventilation to prevent engine fumes from suffocating the crew. Vision slits, periscopes, turret rings, and gun mantlets created tiny gaps in the armor envelope. Under normal conditions, these were negligible. Under WP impact, they became entry points. American tankers learned this not from manuals, but from combat. Accounts from U.S. armored units describe firing WP at German tanks to blind them, to force hatches open, or to compel crews to abandon vehicles. In some cases, the round detonated close enough that burning phosphorus entered the interior, rapidly raising temperatures and filling the compartment with choking smoke. German records acknowledge the effect, though often indirectly. Reports mention tanks being disabled without penetration, crews evacuating under fire, and vehicles lost due to internal fires of unclear origin. Survivors described confusion, disorientation, and overwhelming heat, sensations that armor thickness alone could not prevent. This challenged a core belief within German armored culture, that superior steel ensured survival. Panther and Tiger crews were trained to trust their machines, to hold ground, to fight through incoming fire. WP disrupted that trust. It introduced a weapon that attacked not the tank, but the men inside it. As Allied forces pushed deeper into France and toward Germany's borders, these encounters multiplied. Each one reinforced a lesson that spread quietly through Panzer units. Not every threat announced itself with penetration or explosion. Some arrived as smoke, heat, and panic, invisible from the outside, catastrophic within. And as German crews adapted to this new reality, the battlefield itself narrowed toward moments where decisions were measured not in kilometers or armor thickness, but in seconds inside burning steel. Those moments would define the turning point. From the outside, a German tank appeared solid and imposing. Sloped plates, interlocking armor, and heavy guns projected control. Inside, the reality was far more fragile. 5 men worked in near darkness, surrounded by steel that amplified sound and heat. Engines roared inches away. Shell casings clattered across the floor. Communication depended on shouted commands and discipline under stress. German tank crews were trained to endure this environment. Confidence was drilled into them. Armor thickness was measured, memorized, trusted. When American shells struck without penetrating, crews often remained in position, believing they were safe. The sound of impact alone was not always enough to force withdrawal. White phosphorus changed that calculus. When WP detonated near a tank, its effects were immediate and disorienting. Smoke flooded vision blocks. Breathing became painful. The air grew hot, then unbearable. Crews could not see their instruments. Voices were lost in coughing and confusion. Panic was not a failure of discipline. It was a physiological response to an environment suddenly stripped of oxygen. Veterans later described these moments as uniquely terrifying. Unlike armor-piercing hits, which were violent but brief, WP created a lingering threat. Seconds stretched. Decisions became harder. Should the crew stay inside and risk suffocation, or open hatches under enemy fire? There was no correct answer, only survival. In this way, WP did something rare in armored warfare. It forced trained, experienced crews to abandon machines that were technically still operational. The tank might still move, the gun might still fire, but the men inside could not function. This vulnerability was not discussed openly in training manuals, but it spread through units in quiet conversations and after action debriefs. Armor could stop steel. It could not stop fire and smoke. Tank design in the Second World War prioritized external threats. Armor thickness, slope, and metallurgy were calculated to defeat incoming shells. Fire suppression systems were rudimentary or non-existent. Ventilation was designed for engine exhaust, not chemical smoke. German tanks were no exception. Panthers and Tigers featured advanced armor layouts, but their interiors remained cramped and highly flammable. Paint, insulation, lubricants, and ammunition created an environment vulnerable to heat. Once temperature rose sharply, even without penetration, components failed rapidly. White phosphorus exploited this weakness indirectly. It did not need to breach armor. Its ignition temperature exceeded what internal systems could tolerate. When WP smoke entered a tank, it compromised visibility, oxygen, and thermal stability simultaneously. Crews could not fight blind. Engines overheated. Electrical systems shorted. Ammunition became unstable. American tankers understood this through experience rather than theory. WP was carried primarily for smoke, but crews learned its secondary effects and applied them pragmatically. A WP round near a tank could immobilize it as effectively as a penetrating hit, sometimes more so. This was not a failure of German engineering. It was a limitation of the era. No tank of the Second World War was truly sealed. The battlefield environment ensured that internal conditions mattered as much as external armor. U.S. armored doctrine emphasized flexibility. Crews were trained to recognize when standard methods failed and to adapt under pressure. When facing German tanks they could not penetrate frontally, they did not always withdraw. Instead, they shifted purpose. White phosphorus rounds were often fired deliberately at vision ports, mantlets, or near the base of the turret. The goal was not immediate destruction, but disruption. A blinded tank was a neutralized tank. A panicked crew was a defeated crew. Combat manuals and field reports from 1944 confirm this practice. Tank commanders instructed gunners to load WP when direct fire stalled. Infantry nearby learned to recognize the white smoke as a sign that the enemy tank was compromised. In many cases, German crews bailed out moments later, abandoning intact vehicles that could later be destroyed or captured. These tactics required coordination and nerve. Firing WP meant closing distance, exposing the Sherman to return fire. But when successful, it turned a perceived weakness, lighter armor, into a tactical advantage. By attacking the internal environment rather than the armor itself, Sherman crews redefined what victory looked like in armored combat. And as these lessons spread, they set the stage for encounters where confidence in steel would collide directly with the realities of confined human survival. American armored leadership entered the war with fewer illusions about invincibility. U.S. commanders understood that the Sherman was not the most heavily armored tank on the battlefield, and they did not pretend otherwise. Instead, leadership emphasized coordination, initiative, and the intelligent use of available tools. Field commanders encouraged crews to think beyond penetration charts. After-action reports were circulated quickly. Lessons learned in Italy reached Normandy within weeks. When crews reported that WP rounds forced German tanks to withdraw without penetration, those observations were not dismissed, they were incorporated. This adaptability contrasted sharply with German doctrine. By late 1944, German armored leadership increasingly relied on technically superior machines to compensate for shrinking manpower and fuel shortages. Orders often emphasized holding ground, trusting armor, and fighting to the last round. In such an environment, acknowledging internal vulnerabilities was difficult. American leadership, by contrast, rewarded problem-solving. Tank commanders were trusted to choose ammunition based on circumstance. Gunners were trained to switch rapidly between shell types. This decentralized flexibility allowed WP to become a practical battlefield solution rather than a theoretical one. The difference was not technological, it was organizational. One side adapted doctrine to reality. The other increasingly demanded reality conformed to doctrine. German tank crews were observant professionals. They kept notes. They wrote reports. They learned from each engagement. When WP began appearing more frequently, it forced a reassessment that cut against long-held assumptions. German after-action reports from late 1944 referenced tanks disabled by smoke and internal fires without armor penetration. Crews described abandoning vehicles that were otherwise intact. These incidents were unsettling because they undermined the psychological contract between tanker and machine. Armor was supposed to protect. When it no longer did, morale suffered. Crews began taking additional precautions, sealing hatches when possible, keeping extinguishers closed, adjusting ventilation procedures. None of these fully addressed the problem. A tank could not be sealed in combat. The need to see and breathe ensured vulnerability remained. This growing awareness did not always translate into tactical change. Fuel shortages, Allied air dominance, and operational pressure limited German flexibility. Knowledge did not equal options. Many crews entered battle knowing that survival depended less on armor thickness than on luck and timing. White phosphorus occupied an uncomfortable space in the laws of war. It was legal, widely used, and classified primarily as smoke, yet its effects were undeniably severe. Burns were painful and difficult to treat. Smoke caused panic and suffocation. During the Second World War, WP was employed by all major powers. Its use against armored vehicles was not prohibited, and there is no evidence that American crews violated the laws of war by using it as they did. Still, its impact on those inside tanks left a lasting impression on survivors. For historians, this raises important questions. Warfare is not only about destruction, but about breaking the enemy's ability to fight. WP did not always destroy tanks. It destroyed the conditions that made fighting possible. As Allied forces advanced toward Germany itself, these moral and practical realities converged on the battlefield. Encounters became closer, stakes grew higher, and moments emerged where a single shell, not penetrating, not explosive, would decide whether a crew lived, fled, or died. Late January 1945, Western Germany. A landscape scarred by months of retreat and resistance. Villages that once marked boundaries on maps had become killing zones. Stone houses offered cover, narrow roads funneled armor into predictable paths. Snow and mud limited movement, forcing tanks into exposed approaches. In this environment, every engagement unfolded at close range, often without warning. A U.S. armored column advanced cautiously along a sunken road. Infantry moved ahead on foot, scanning hedges and ruined walls. The Shermans followed at intervals, engines low, turrets scanning. Intelligence suggested German armor was nearby, not a large force, but experienced crews defending ground they could not afford to lose. The first contact came suddenly. A German Panzer IV emerged from behind a farmhouse, its gun already traversing. The initial exchange was fast and violent. Armor-piercing rounds struck both tanks. The Sherman's shot glanced off the Panzer's frontal plate. The German returned fire missed narrowly, tearing into the earth behind. The American tank commander made a decision in seconds. He ordered WP. The gunner switched ammunition. The Sherman fired again, this time aiming low and short. The shell detonated against the Panzer's glacis, bursting into dense white smoke. It clung to the metal, pouring over the turret roof and down the sides. Inside the German tank, conditions changed instantly. Visibility vanished. The gunner lost sight of his target. The commander could no longer see through his periscope. Smoke entered through the gun mantlet and ventilation system, filling the fighting compartment. The temperature rose sharply. Breathing became labored. Orders were shouted, then lost in coughing. The Panzer did not explode. Its armor held. But its crew was no longer fighting. Outside, American infantry recognized the signs. The white cloud meant the tank was compromised. Riflemen and engineers moved forward, covering the Sherman as it repositioned. Another WP round followed, this one striking near the turret ring. Moments later, the German commander opened the hatch. He did not emerge firing. He emerged gasping, followed by the rest of the crew, abandoning a tank that minutes earlier had been a position of strength. Some collapsed in the snow. Others stumbled toward cover, hands raised. The engagement ended not with a penetration, but with evacuation. Similar scenes unfolded across the front in the winter of 1945. In villages, at crossroads, along frozen fields, Sherman crews faced German armor that outmatched them on paper. They responded not with brute force, but with controlled disruption. WP rounds blinded, suffocated, and overheated interiors. Tanks were neutralized. Crews fled. German commanders took note. Reports described losses without visible damage. Tanks listed as abandoned rather than destroyed. The distinction mattered because it signaled a deeper shift. Armor superiority no longer guaranteed control of the battlefield. As these encounters accumulated, confidence drained from Panzer units already stretched thin. Every engagement carried a new uncertainty. Not whether the armor would hold, but whether the interior would remain survivable long enough to fight. And as winter wore on, these moments converged toward a realization that neither side could ignore. By February 1945, the pattern was unmistakable. German armored units were still capable of inflicting losses. Panthers and Tigers continued to knock out Shermans when positioned well and supplied adequately. But something fundamental had shifted in how engagements ended. Increasingly, tanks were not being destroyed, they were being emptied. In one village after another, American after-action reports described the same sequence. Contact at close range, initial armor-piercing fire proving ineffective. A rapid switch to WP, white smoke enveloping German vehicles. Crews abandoning tanks that remained mechanically intact. From the American perspective, this was not seen as cruelty or innovation. It was simply effective. Tankers did not celebrate it. They recorded it. WP was a tool that solved a problem when other tools failed. For German crews, the effect was corrosive. Tank warfare depended on trust in machinery, training, and protection. WP eroded that trust silently. A Panther that had survived artillery air attack could be rendered uninhabitable in seconds. A crew that believed it could hold a position indefinitely suddenly faced a threat that did not announce itself with penetration or explosion. Veterans later recalled how the sound of a WP impact differed from armor-piercing fire. There was no immediate violence. Instead, there was heat, smoke, panic spreading faster than orders. Commanders struggled to maintain control when visibility vanished and breathing became painful. Some crews tried to fight through it. They sealed hatches, reduced ventilation, and continued firing blind. In several documented cases, this decision proved fatal. Oxygen depletion and rising temperatures incapacitated crews before relief could arrive. Tanks were later found with crews still inside, overcome rather than killed outright. These incidents accelerated a psychological turning point. German commanders, already under pressure from collapsing fronts and fuel shortages, now faced armored units that hesitated. Crews became quicker to abandon tanks when WP'd. This was not cowardice, it was learned survival. Once the interior environment became hostile, discipline could not compensate. American units exploited this shift deliberately. WP rounds were fired early in engagements to disorient and suppress, followed by armor-piercing or infantry assault. The sequence became doctrine in practice, even if it was never formally codified. The turning point, then, was not a single battle or date. It was a realization shared across the front. Armored warfare was no longer decided solely by penetration statistics or gun calibers. It was decided by control of the human environment inside the machine. By early spring, German armored resistance was increasingly fragmented. Tanks appeared, fired briefly, and withdrew. Some were abandoned without firing a shot once WP smoke filled the air. The battlefield had changed, and the men inside the armor knew it. This shift carried consequences that would echo beyond the war itself, into how armies understood protection, survivability, and the limits of steel. When the fighting moved eastward and the front lines collapsed, the material evidence of what had happened remained scattered across the landscape. Abandoned German tanks stood in villages, fields, and forests, many with no visible armor damage. Their guns were intact, their tracks unbroken. Hatches stood open. Allied inspection teams took note. Intelligence officers cataloged these vehicles, comparing exterior condition with internal damage. In many cases, the interiors were scorched, paint was blistered, equipment was warped. Ammunition racks showed signs of heat exposure rather than penetration. These findings aligned with battlefield reports describing WP effects rather than conventional armor defeat. Casualty figures reflected the shift. German armored losses increased not only through destruction, but through abandonment. Tanks that could have been recovered earlier in the war were now left behind due to lack of crews, fuel, or morale. Each abandoned vehicle reduced combat power more permanently than a destroyed one, because replacement crews no longer existed in sufficient numbers. American armored units also recorded changes. WP usage was noted explicitly in operational summaries, particularly in urban and close terrain. Commanders emphasized its effectiveness for suppression and crew neutralization rather than tank destruction. It became one of several tools used to break resistance without prolonged firefights. German reports from early 1945 reveal a growing preoccupation with internal survivability. Crews requested improved ventilation and fire suppression systems, requests that could not be fulfilled under wartime conditions. Some units improvised additional sealing or carried extra extinguishers, but these measures offered limited protection against WP smoke infiltration. Psychologically, the effect was significant. Survivors described a loss of faith in armor as absolute protection. Tanks were still necessary, but no longer reassuring. Entering combat meant accepting that survival might depend on factors beyond steel thickness or gunnery skill. This erosion of confidence coincided with worsening strategic realities. Allied air dominance limited movement. Fuel shortages restricted training and recovery. Replacement crews lacked experience. In this environment, any weapon that accelerated crew abandonment had an outsized impact. By the time Allied forces crossed the Rhine, German armored units were shadows of their former strength, not solely because their tanks were destroyed, but because the men who once trusted those machines were gone. And as the war ended, analysts on both sides began to understand that what had unfolded was not merely a tactical adjustment, but a lesson about the limits of protection in modern warfare. In the months following Germany's surrender, Allied analysts examined the armored war with unusual attention. The conflict had not only consumed machines, but doctrines. Many conclusions focused on production, gun calibers, and armor thickness. Yet beneath these technical assessments lay a quieter realization that the interior environment of a fighting vehicle mattered as much as its exterior protection. White phosphorus was part of that realization. Post-war reports did not single WP out as a decisive weapon on its own. Instead, it was discussed as a force multiplier, a means of disrupting crews, denying terrain, and accelerating collapse when resistance was already strained. Its effectiveness against tanks was acknowledged indirectly, often framed in terms of smoke-induced abandonment rather than incendiary damage. German veterans echoed these assessments in later memoirs and interviews. Many emphasized that fear was not of the shell itself, but of what followed: smoke that could not be seen through, heat that could not be escaped, the knowledge that staying inside might be more dangerous than exposing oneself outside. These reflections influenced post-war armored design. Tanks developed after 1945 placed far greater emphasis on crew survivability beyond armor. Improved ventilation systems, fire suppression, sealed compartments, and later overpressure protection against chemical threats all traced part of their lineage to lessons learned in confined steel boxes during the Second World War. For the United States, the experience reinforced doctrinal confidence. Sherman crews had compensated for technical disadvantages through adaptability and coordination. The use of WP was not a doctrine in isolation, but a symptom of a broader approach, one that prioritized solving battlefield problems pragmatically rather than adhering rigidly to theoretical superiority. The moral discussion continued as well. WP would remain controversial in later conflicts, its effects scrutinized and debated. But within the historical context of 1944 and 1945, its use against armored vehicles was legal, widespread, and driven by necessity rather than experimentation. What mattered most in the aftermath was not the shell itself, but what it revealed. Armor alone was not enough. Protection had to account for human limits: breathing, sight, heat tolerance, panic. Tanks were not invulnerable fortresses. They were sealed environments carrying men into extreme conditions. Once those conditions turned hostile from within, no amount of steel could compensate. This understanding reshaped how armies thought about survivability. It shifted focus from simply resisting penetration to preserving function under stress. And it marked one of the many subtle ways the Second World War transformed warfare, not through a single invention, but through accumulated experience paid for in fear, smoke, and heat. Those lessons lingered long after the last tank fell silent. Armored warfare in the Second World War is often remembered through images of massive guns and thick steel. Tigers advancing through smoke, Shermans burning in fields. Armor measured in millimeters, penetration charts studied like scripture. Yet the reality experienced by the men inside those machines was more intimate and more fragile. A tank was never just armor. It was air that had to be breathed, heat that had to be endured, vision that had to be maintained under shock and noise. When those elements failed, the machine ceased to function, no matter how thick its plates or powerful its gun. White phosphorus did not change the war by itself. It did not win battles alone, and it did not replace skill or courage. What it did was expose a truth that armored doctrine had long obscured. Survival depended on the human environment as much as the mechanical one. The moment a tank became uninhabitable, it stopped being a weapon. For German tankers, this realization came late and under pressure. For American crews, it became one more lesson absorbed through combat, that adaptability could offset technical disadvantage. The Sherman, often criticized for what it lacked, proved effective because it fit into a system that allowed crews to think, react, and survive. The legacy of those encounters lives on in every modern armored vehicle. Fire suppression systems, sealed compartments, and crew protection measures all trace their origins to lessons learned in cramped, burning steel during the final years of the war. In the end, the story is not about a shell, or a tank, or even a battlefield. It is about the limits of protection. Steel can stop a projectile. It cannot stop fear, heat, or the need to breathe. And that truth, learned in silence and smoke, reshaped warfare forever.